The need for action was immediate. Science had already established cause and effect, and it was now up to world leaders and managers and engineers to find the solutions. Fortunately, an excellent short-term solution was at hand. This time, the magic molecule was the hydrofluorocarbon, also known as tetrafluoroethane, a close yet significantly different relative of the CFC. This molecule would not present any threat to stratospheric ozone, but it's important to note that it has a very high potential for trapping infrared radiation and enhancing the greenhouse effect. Soon, HCFCs would fill the aerosol cans, which all sported the new eco-friendly labels of no CFCs. CFCs were carefully collected and disposed of from old refrigerators and air conditioners. Developed countries took responsibility upon themselves for setting rigid deadlines for phase-out of ozone-depleting substances, granting additional concessions and support to the developing world and the less developed countries, for their contribution to the problem was significantly less than that of the more developed countries. Such was the success of the Montreal Protocol that it prompted the former Secretary General of the United Nations, Kofi Annan, to describe it as perhaps the single most successful international agreement to date. Perhaps the most significant reason behind the success of the Montreal Protocol was its adherence to the principle of common but differentiated responsibility, with the developed countries, the MEDCs, taking the lead and willing to phase out ODS in the short term while giving extensions to nations like China and India to follow up with a later date for their phase-out. Other reasons for the success and the prompt action include the fact that science was able to clearly identify the cause and the effect, and then they were able to provide a cheap and viable alternative in the form of the HCFC. The cost of implementing the solution, changing over from CFC to HCFC, was minimal, and when weighed up against the benefits, it was a very easy decision to make. So the cost-benefit analysis looks something like this, with the cutting back or the abatement of ODS moving in this direction, and for each unit of CFCs that's phased out, the benefit shown here. But what was the cost of this phase out? Because the cost of it was so low because of the ease of implementing the solution, then significant amounts of reduction occurred, bringing the level to this equilibrium point here, where the green overlaps with the blue. And it's just a matter of time before complete phase-out occurs and the green line becomes yellow. The current equilibrium is at this point, however, for there is still some additional phase-out that remains. For the moment, however, there are still some ODS that go into the atmosphere. These come from sources like metered dose inhalers, which receive special exemption from the provisions of the Montreal Protocol and the Clean Air Act in the United States. Another exempted category is methyl bromide, which was officially phased out in the US in 2005, but still receives a QPS, or quarantine and pre-shipment exemption, for use in controlling pests in foods that are shipped overseas.